Hey guys, this is Coach Brian bringing you your Unit 9 test review. I just want to begin by saying that these dates you can see are from last year. This test for A days will be on the 30th, and for B days will be on the 1st. All right, so everything you see up here will be provided for you on the test. You'll have the blank magic hexagon, you'll be given the odd even functions, and you'll be given the cofunction identities. The biggest thing you'll need to remember is how to fill out the hexagon. You start with tangent on the left, and then you just need to remember that it equals sine divided by cosine. And then you go across from all of these and put their reciprocal trig function. Now, another thing you could do is draw a second one of these and make them all squared. Or you could just do it on your original one. I just don't want you to be confused when you're doing reciprocal functions versus Pythagorean functions. So, biggest things to remember are that no matter where you start, the first thing equals the second over the third. So if I go this direction from tangent, okay, I could write tangent x equals sine divided by cosine. I could also go this direction, and I would get that tangent of x equals secant divided by cosecant. And this rule also applies if I go across. I could say that tangent equals 1 divided by cotangent. So that's what I mean when I say first equals second divided by third. Another thing we could do using this is when they're squared, we can use the Pythagorean sevens. Pythagorean sevens. Anywhere that you could make the number 7 inside of this hexagon, which is 3 spots, 1, 2, and 3. Anywhere that you can make a 7 that's upright, you can follow that around, and it's, for instance, sine plus cosine equals 1. 1 plus cotangent equals cosecant, or tangent plus 1 equals secant. And then once you have one of those sevens, as we've been calling them, you can rearrange it to equal whatever you want. I suggest using it a lot, like mapping everything out using the original from here and being very careful about what your signs look like. The last thing is the cofunctions, which are on the same plane with each other, if you want to think about it like that. Cofunctions. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. And that's where these cofunction identities come in. All right, so let's actually get started. The entire first page is full of true or false problems that, to get them, you really have to understand your odd even, your cofunctions, and your first equals second over third. You really have to have kind of a good grasp on all of your identities. So the first one we're going to start with, it says that sine 15 equals cosine 15. So sine and cosine are cofunctions. And when you have cofunctions, which you can look up here if you need to, you can look up here, sine of an angle should equal cosine of 90 minus that angle. So if I have sine of 15, it shouldn't equal the cosine of 15. It should equal the cosine of 90 minus 15, which is the cosine of 75. And the 15 and the 75 are complementary because cofunctions, they're equal when they're complementary. So this is actually false. The next question, you can see we have a negative input and we get a negative output. However, cosine is an even function, which means the cosine of 20 and the cosine of negative 20 should be, sorry, I just made that worse the whole time, should be the same. So this is false because cosine of negative 20 really equals cosine 20. I'll jump over now so that I'm not scrolling up and down a whole lot. We've got secant, same thing, negative input, negative output, but secant and cosine, just like this one we worked right here, secant is even. Secant is even, which means that if I plug in positive 20 or negative 20, I should get the same answer. So this is false. Next, I have sine over 15 equaling 1 over cosecant of 15. Now this one, the way it's set up, it looks like a reciprocal function. And so I want to first make sure that these things are reciprocals. So if I go to my hexagon, reciprocals are across from each other, all right, all the way across. And the reciprocal of sine is cosecant. And if you look, sine, the first thing, equals 1 over cosecant. Sine equals 1 over cosecant. So if I have the sine of a number, it equals 1 over the cosecant of that same number. So this is true. Still going on now. We've got cosecant of 25 equals the secant of 25. These two are cofunctions, but remember what we said earlier is that when you have cofunctions, the numbers should be complements, which means together they add up to 90. And 25 is not the complement of 25. Those only add up to 50. And so the cosecant of 25 should equal the secant of 90 minus 25, which is 65. So this is false. Now this next one looks close. Cosine and sine are cofunctions, and 15 and 75 are they're complementary, but the fact that the sine is under 1 throws off this entire thing. throws off the entire thing. Sine is not the reciprocal of cosine. So there's a couple ways you could write this to make it true. You could say cosine 15 equals sine 75. That's one way. Or you could say that it equals 1 over the secant of 15. So there's two different ways you could make this true, but as of now, it's false. Now we've got a similar looking problem over here. We've got cosecant and secant. Those are cofunctions. However, just like we had over here, it's under 1 and they are not reciprocals of each other. So these are like kind of mixing, the one we just did and this one, they're kind of mixing concepts that are making them wrong. So how could we make this true? Well, we could actually say that it cosecant of 22, you could say that it equals the secant of the complement, which would be 68, or you could say that it equals 1 over sine 22. So either one of those would make it true, but as of right now, it's still false. All right, tangent with a negative input. Tangent is odd. Tangent is odd, which means if I have tan of 25, and let's just say it gives me x. No, it's an output, so let's make it y. But I have tan of negative 25. The answer is still going to be y, but it's going to have the opposite sign. So this is false because tangent is an odd function. This would be true if tangent was even, but sine and tangent are odd. Cosine is even. All right, now moving to the next row. We got sine and cosine, which are cofunctions. They're cofunctions. And we've got 15 and 75, which equal 90. So this is true. This is true. Sine 15 is cosine 75. If you're unsure really about any of the ones we've done so far, you could always type the two things into your calculator and see if they equal each other. On this next one, we've got tan and cotan, which are cofunctions. And we've got 30 and 60, which together add up to 90. So this one's also true. And then we've got secant and cosecant, which are cofunctions. They're cofunctions. And the way it's set up right here is as a reciprocal, but they are not reciprocals. The reciprocal of secant, so there's two ways I could make this true. I could say secant 35 equals, and it would need to still be cosecant, but not under 1, and it would need to be the complement to 35, which is 55. So that could be true. Or I could say that secant 35 equals 1 over cosine of the same number, so 35, because those are reciprocals. But these are neither one, so this is false. And then lastly, tan and cotan, They are cofunctions. And this one at first might catch you off guard. 45 and 45, you're like, cofunctions, but it's the same number, so they're wrong. However, 45 and 45 are complements, so this is actually true. So, you have to have a good understanding of the reciprocals, the cofunctions, and even odd. Reciprocals, cofunctions, and even odd. That's all for this part, and in the next part, I'll do page 2.